When using a spectrophotometer, you would scan across all wavelengths of light in order to determine the best possible wavelength to find absorbance for the specific sample. This value is usually the lambda max. Additionally, when you scan across all wavelengths of light, you are identifying a solution. This can be done by comparing the peaks of the graph in the scan to the reference graphs provided. The lambda max is the area of the spectrum produced by the spectrophotometer when the substance has the highest absorbance value. The lambda max is identified by observing the highest absorbance value peak while scanning across all wavelengths.
Here we can see the equation for Beer-Lambert law. A is the absorbance of a solution. This represents how much light the solution absorbs. Epsilon is the molar absorption coefficient, which comes from how strongly a chemical absorbs light. C is the molar concentration of the solution in moles per liter. L is the optical path length in centimeters. This variable is determined by how long the light beam from the spectrophotometer travels through the solution in the cuvette. As seen in the equation, absorbance is directly proportional to molar concentration. This means that as molar concentration increases, the absorbance increases too. If you fail to zero the spectrophotometer with a blank solution, there may be an error in determining the absorbance of the solution, as the machine uses the blank solution as a reference to know how much absorbance is in a solution is due to the water or other solvent in the solution.
Here we can see each group member transferring the correct amount of solution into the cuvette. Each group member is checking to see if the spectrophotometer has been zero before we start. The two sides of the cuvettes are being lighted by each group member. Each group member places the cuvette with the clean sides facing the beam. The spectrophotometer is closed before the scanning begins. Then we scan the absorbance of the sample. Each absorbance scan will then be recorded into the notebook. Each member carefully removes each sample from the spectrophotometer and closes the door once removed. All members of the group are required to clean up the work area once they are done with experiments.
Here in the notebook, we see that as each dilution becomes less concentrated, the absorbance values for the dilutions decrease as well. This shows the direct relationship between absorbance and concentration seen previously in Beer-Lambert law.